Welcome back. We're going to get started. And the first thing I really want to teach you, that's something probably is easy, and I think most everybody should be able to do this on the first attempt. Because again, you start off slowly and work your way up into the more complex concepts. But again, your foundational has to be really, really strong if you're going to build on it. All right. And I felt this is the right place to start. Without further delay, let's get started. Now, if you remember that when I mentioned about an atom, there are 5 components: a nucleus, the orbitals, protons, electrons, and neutrons. Now, pretty much all of this will be present in all elements except one, for which there will be no neutrons. We're going to see that in just a minute. Okay? But you will see that they're all present. At least you should try to make an attempt to calculate the number of protons, electrons, and neutrons for an element and an ion. Okay, and that's the objective of this video. Okay, we're going to decode how to understand the numbers shown inside a specific box or a cell for a particular element when it's in its neutral state, that it is neither positive nor negative. And then when an element becomes an ion, which is where most of the time it's going to be, when, for instance, your body contains sodium chloride, it's not existing as sodium element or chloride element in its neutral state. It's existing as sodium and chloride ion. You see how I'm using the terms ion versus element. An element could be in its neutral state, but it could also be an ion. All right, so that's how we're gonna basically quantitatively determine how many protons, neutrons, and electrons are there for a particular element or a particular ion. And like I said, this is one of the favorite topics for any student because there's really absolutely no chance you can get this one wrong. All right, so atomic number and atomic mass. So you see, it's only the second video, and I've already introduced to like 7 different terms. And imagine at the end of the course how many technical terms you would know. And that's why we need to know shortcuts from the periodic table to make our lives easy, which is why I called it a blueprint. Okay. For instance, if you look at the periodic table, you would see this arrangement. You would see that one element always is a whole number, which is always at the top. Now, like I said, we're going to use the periodic table that I have given you for this class. This may flip in some other Google images, and that's why I said stay away from it. And you see one that's almost always decimal, and one is always atomic, the whole number. This is your atomic number. Okay, I think I actually have a PowerPoint. Okay, atomic mass. Okay, the whole number is atomic number, and the fractional value is always atomic mass, and they usually appear for top atomic number, bottom atomic mass. This is the International Union of Pure and Applied Chemistry's registered format, so stick with it. All right, atomic number corresponds to the number of protons and electrons. For instance, Mg is magnesium. Okay, Mg is, you do not have to memorize it, as I would never quiz you what Mg stands for, because that's not the purpose of this class. Okay, and you can use Google or any other place to find what Mg is. I don't care, because this is an online environment, so I can't control what you can do, but I will not test you what the symbol and the name of the element is. An atomic number corresponds to the number of protons and electrons. What do I mean by that? For instance, magnesium is 12. So I have a statement here that says an atomic mass corresponds to mass of protons plus mass of neutrons. Okay, that's how this value is determined. Okay, this is not saying anything about how many neutrons we have. You see, be careful. Atomic number actually tells you the number of protons and electrons, whereas atomic mass does not tell you how many neutrons do you have, but you have to account for the number of neutrons as well. All it says is atomic mass itself means it's a mass of protons plus mass of neutrons. All right, so let's go back up. And as I said, magnesium's atomic number is 12. So all it contains is 12 protons and 12 electrons. Now P is for protons, lowercase, okay? And E is for electrons, okay? Now you may also see some other textbooks or some other authors. If you don't like my video and you're going to jump in YouTube anyways to find somebody else's video, you might see the person write E minus and you think my instructor writes E. You can write E, E minus, it does matter, okay? Along these lines, I also want to point out, try to stay away from external resources, because what I have done here is concise material to the point. So if you don't understand, ask me, because going to too many outside resources means you're now looking at too many variables and you end up going to waste your time, okay? Which is very, very important. You cannot waste time. Now, we know that if you know the atomic number, we know how many protons and electrons we have. But we still don't know how many neutrons we have, because the atomic mass itself does not offer a precise definition for how many neutrons we have. But there's a way we can calculate it. So how to find number of neutrons? Number of neutrons is atomic mass rounded to its nearest whole number minus your atomic number. Now this, I want to add a statement, okay? If the first decimal place, okay, for instance, in this case, 24.3, I'm going to only underline the 3. If your first decimal place is 0.5, is less than 0.5, okay, less than 0.5, then you round it below, okay, round below, okay. So it'll be 24, okay. But what if you have, which we're going to see in another example. So your first decimal place, if it's less than 0.5, okay, and it is, right? It is less than 0.5, right? Well, think about it this way. Think of it as less than 5. Some of you may ask, hey, it's not doesn't look like 0.5 to me. Well, it is what it is, but you can think of it as less than 5, if that's what helps you. Whatever it is, this number, if it's 0, 1, 2, 3, 4, then you round below. If this number is 5, 6, 7, 8, 9, then you round above. Does that make sense? All right. So how do we find the number of neutrons in magnesium? Well, as I said, I stick to my guts and I stick to what I say as well. So 24.3, so it's 24, and the number of atomic number is 12, so we got 12 neutrons. And I don't believe there's a different way of writing neutrons. It's always going to be 12n, and so that's how you calculate the physical quantities of how many protons, neutrons, and electrons you have in a particular element. So let's look at one more example. So here we got phosphorus 15, 30.97. We know right away that this is our atomic number, right? And this is our atomic mass, right? So how many protons and electrons we have? Number of protons would be, well, atomic number is 15, so we got 15, or 15p. Number of electrons would be, well, that's also 15. And then, well, you see this decimal place is greater than 0.5, or thinking of 5, greater than 5. So you round it off to the nearest whole number above. So in this case, 30.97, this decimal is greater than 0.5. So round above, okay? What I mean by round above is you round below to the nearest whole number, you round above to the nearest whole number. So this would essentially become 31. So that means Number of neutrons would be 31 minus 15, and that is 16 neutrons. Right. I'm going to stop the video here because I want to make another video on ions, explain what an ion is, and then bring this concept that you just see on the screen for a positive ion and a negative ion. I could have actually compiled it in this video, but it does two things. It makes the video long, and you're going to end up learning too many things in one single video, which is not the philosophy of this class. Okay, I don't want to give you a buffet of items all at one time and not help you actually taste even one food that you can say, hey, it's good. All right, I don't want that. I want you to have little meals at a time, and that's perfectly fine with me. Right? So this is how you decode the information about the numbers for a particular element in a periodic table. This works for any element that you want to work on in the periodic table, as long as it is neutral. All right, so stay tuned for how we're going to deal with this for ions.